Founded in 1874, Watts Regulator is a pioneer in the manufacture of valves and the promotion of public safety. Watts is currently the leading valve manufacturer in the United States, producing over 60,000 valves a day to handle a wide range of applications. But Watts is much more than a manufacturing company. We've taken a leadership role in the valve industry, guided by the principle of safety first. For us, that translates into a strong commitment to education. We educate the industry on hazards threatening public safety and develop standards and regulations for protecting against those hazards. We distribute valuable information through a range of media, from seminars to newsletters. The most effective method of education is provided by 36 trained sales and engineering representatives in the United States and additional representatives in Canada and around the world. The combination of manufacturing and marketing leadership and strong distribution make Watts the preferred source in the industry. It's the world leader in temperature and pressure relief valves and in water pressure reducing valves, including an automatic control valve. Watts also manufactures a full line of quarter-turn ball valves, including a complete automated control valve package. And the company produces specialty products that cater to small niche markets, such as water tempering valves, water hammer shock arresters, hydraulic heating specialties, strainers, and dielectric unions, to name a few. And finally, Watts leads the industry in the fastest growing product line, backflow prevention devices. These safety valves protect drinking water from the hazards of water flowing in reverse from contaminated sources. Fact: in November 1988, anti-rust chemicals from a boiler seeped into a Kansas City school water supply. Result: 64 students and teachers were tested for traces of chromium. Fact: in Connecticut, liquid propane leaked into a town's water supply during unauthorized maintenance operations by a utility company. Result: explosions, fires, injuries, and $2 million in cleanup costs. Fact: in an Illinois hospital, a kidney dialysis machine became contaminated with antifreeze from an air conditioner. Less than a year later, a similar incident took place in a New York hospital. Result: the needless deaths of 2 patients. When multiple cases like this occur, it's a sure sign of a high-risk condition. The general public tends to take safe drinking water for granted and doesn't expect situations like these to happen. But in fact, serious cases of contamination are reported every year, many of which could have been prevented. That's why we made this tape and distribute documents such as Stop Backflow News, to alert you to the problems of drinking water contamination and to show you what can be done to prevent these problems from arising in the first place. A major source of water contamination is backflow. Backflow is the unwanted reverse flow of liquid in a piping system. This situation occurs whenever the outlet pressure becomes greater than the supply pressure. Backflow is particularly dangerous at cross-connection points. A cross-connection is defined as a physical connection between 2 separate piping systems, where one contains safe drinking water and the other could contain a contaminant. Wherever a piping system allows a drinking water line to connect to a line carrying polluted fluids, contamination is a serious possibility. Cross-connections are an integral part of all facilities with plumbing systems, from industrial complexes to your own home. The danger comes from unprotected cross-connections. Consider the garden hose, one of the most common cross-connection offenders. If it's left lying on the ground, it can become contaminated by fertilizers or pesticides. Should backflow occur, the hazardous mixture will flow back into the drinking water supply. When you consider that every day approximately 100,000 new unprotected cross-connections can be created, you can appreciate the magnitude of the problem we face. A significant number of documented cases of backflow has caused both the federal government and the insurance industry to take action. The federal government acted to upgrade water quality in 1974 by passing the Safe Drinking Water Act. This law, reaffirmed and strengthened in 1986, sets minimum standards for safe drinking water from the source to the tap. Under EPA guidelines, all community water systems must have a state-approved program for protecting safe drinking water. Insurance companies have also taken action as a result of costly lawsuits arising from backflow contamination incidents. For example, in October 1986, sodium hydroxide from a chemical plant in Lacey's Chapel, Alabama, backflowed into the safe drinking water supply. A $16 million lawsuit was filed. In June 1987, water service for 63 properties in Hawthorne, New Jersey was shut down when a pesticide was siphoned into the public drinking system. The accident followed a water main break during bridge construction. A $21 million lawsuit is pending. Because of incidents such as these, insurance policies now include riders that exempt coverage for water pollution and contamination. This means that any water authority that allows customers to tie into a community system can be held liable for negligence if backflow occurs. The key is for the water authority to change existing regulations governing water safety and take reasonable care for all foreseeable backflow circumstances. How is this accomplished? The answer is to institute a complete backflow prevention program. A successful program includes two essential parts. The first strategy is cross-connection control, detailed in all plumbing codes. This step requires the installation of appropriate backflow valves wherever an actual or even a potential cross-connection exists. The second part of a backflow prevention program, one that's equally important, is containment control. This is accomplished by requiring a backflow prevention device at the consumer's water meter, fire protection service, or other point of supply. Containment control is recommended by the American Water Works Association as the best method to back up plumbing code cross-connection controls. Too often, people assume that following one of these steps is sufficient. We at Watts caution: don't be satisfied with being half safe. Cross-connection control prevents backflow at the source. Containment control provides additional insurance if there's an oversight in the cross-connection control program. Only if both steps are taken can we maintain safe drinking water and protect against liability. An effective backflow prevention program is the joint responsibility of the water authority and the consumer. If the consumer is not included in the prevention program, the water authority needlessly assumes the total legal liability for safe drinking water. How are the responsibilities divided? The short answer is, the water authority regulates and the consumer complies. Let's go over what this means. The water authority provides a formal backflow prevention program and requires compliance by the consumer. The consumer is responsible for the safety of the water from the water meter to the point of use. Backflow prevention programs require the consumer to comply with plumbing and health codes for containment and cross-connection control by obtaining the services of certified professionals, such as plumbing contractors and inspectors. The consumer is ultimately responsible for seeing that certified plumbers carry out the following actions. 1. Comply with the latest safety precautions. 2. Conduct a survey to locate all actual and potential cross-connections on the property. 3. Install, test, and maintain backflow prevention devices for all cross-connections. 4. Submit proper records to the water authority. Watts Regulator can supply you with a complete line of backflow prevention products for comprehensive cross-connection control. Unlike some of our competitors who assemble their products, at Watts, we do our own manufacturing. This gives us superior quality control and safe operation of our products. We totally control product design and manufacture. We even make many of our own tools in our machine tool shop, and we test every device 100% before it is shipped. Watts continually invests heavily in manufacturing integration to control quality, costs, and efficient operations. For example, our extensive foundry operations protect us from the current crisis caused by the reduction in bronze foundries. We also use advanced machining equipment, such as single and multi-spindle screw machines, a fused epoxy coating system, stamping equipment, and automated subassembly. One of the more impressive pieces of equipment is the Matsuura numerical control lathe, which machines complex backflow prevention devices in a single, smooth operation. This state-of-the-art lathe machines in a single operation products that formerly took 8 operations. This assures that our valves are made with consistent dimensions. The Watts commitment to maximum safety is also evident in our complete compliance with industry standards. Watts products meet and often exceed all applicable industry standards. Watts has even developed products for which no standards exist. We see it as our ongoing responsibility to lead the industry in safety by developing new and improved devices for backflow prevention. Earlier, we mentioned that the consumer is responsible for conducting a survey to locate all unprotected cross connections in his water system. The survey determines which type of backflow prevention device should be used at each cross connection. The 2 major factors which determine the appropriate device are the level of hazard and the hydraulics of the system. The hydraulics indicate whether a back siphonage, back pressure, or continuous pressure device is appropriate. In back siphonage, reverse flow is caused by a negative pressure or vacuum in the supply piping. In back pressure, reverse flow results when the downstream pressure is greater than the supply pressure. Let's now examine the 6 methods of backflow prevention. For each device, we'll give the hydraulics and hazard conditions met by each method. That will help you choose the appropriate valve for the condition of the cross connection. It's not very cost-effective, for example, to use a high-hazard device for a low-hazard cross connection. The first method we'll cover is the air gap, the only method not requiring a mechanical device. An air gap is the physical separation by an airspace of drinkable water and an open container holding non-drinkable liquid. Although air gaps have several specialized applications, such as laundry sinks, they have some serious limitations. For example, because the system is open, it's exposed to atmospheric pollution. And because much of today's complex piping systems require continuous pressure, the air gap's use of discontinuous piping is not very practical. The reduced pressure zone backflow preventer, known as the RPZ, delivers the greatest protection against backflow. Watts increases the level of safety by testing the RPZ valve twice before shipping. The RPZ device can be used on all direct connections subject to back siphonage or back pressure, or a combination of the two, and on systems operating under continuous pressure. RPZ devices are used in high-hazard cross connections. Watts manufactures 2 types of RPZ devices, the 009 Standard Series and the 909 High Capacity Relief Series. Both types are designed for easy maintenance with removable seats and bolted covers. No special tools are required to service either model. The 909 series is the most sophisticated RPZ device available, offering extra protection through an additional vacuum relief port which significantly increases the valve's relief capacity. It has 3 times the capacity to vent water as the 009 series. The 909 series is required for the extremely hazardous condition of combined back siphonage and back pressure, with both checks fouled. When would this dangerous situation occur? It often starts as a back siphonage condition, which can cause other hydraulic and mechanical conditions in the system. By stirring up debris in the water, back siphonage can cause checks to foul and induce back pressure, which can in turn lead to excessive flooding in the assembly. If the relief valve then reaches its maximum capacity for discharge, its ability to function is greatly impaired. Typical installations for reduced pressure zone devices include main supply lines, boiler feed lines, irrigation and lawn sprinkling systems, and other high-hazard cross connections. The double check valve assembly consists of 2 independent check valves. This device protects against back siphonage or back pressure when at least one check is holding. This type of valve is used under continuous pressure, low hazard conditions. Watts manufactures two double-check valve assembly product lines, the 709 and 007 series. Typical installations include food processing equipment, lawn sprinklers, non-toxic fire sprinkler systems, and other low-hazard applications. A related product, the double detector check valve backflow preventer, prevents the reverse flow of fire protection substances. Watts produces the 709 DDC product for low hazard conditions and the 909 RPDA for high hazards. It is installed in fire sprinkler lines and detects underground leaks and unauthorized use of unmetered water that could cause extremely harmful contamination. The pressure vacuum breaker is used on connections to non-potable systems. It protects against back siphonage, but not against back pressure. It may be used under continuous pressure and for low or high hazard cross connections. The Watts 800 series pressure vacuum breaker is ideally suited for industrial process water systems and other continuous pressure piping systems. Typical applications include irrigation and lawn sprinkler systems, laboratory equipment, and livestock water systems. Pressure vacuum breakers also include backflow preventers with intermediate atmospheric vent. They protect against back siphonage or back pressure in conditions of continuous pressure. This device is used in low hazard conditions. Watts makes two valves of this type, the 9D and 9BD series. Both are used specifically for small pipes. The 9D is used on laboratory equipment, dairy equipment, and processing tanks, and is particularly recommended for residential boiler feed lines. The 9BD is specially designed for beverage vending machines. Its stainless steel body is a Watts innovation, protecting against copper sulfate poisoning caused by beverage dispensers' copper tubing. Here is a case where Watts set the national standard. We simply saw a need and devised a solution without the motivation of the government's stamp of approval. An atmospheric vacuum breaker is used only on cross connections where back siphonage is a potential hazard. It does not protect against back pressure. Unlike the pressure vacuum breaker, the atmospheric type cannot be used under continuous pressure. But like the pressure vacuum breaker, the atmospheric type protects against both low and high hazard conditions. Watts manufactures two atmospheric vacuum breakers, the 288A and 388ASC. They are recommended for potable feeds to receptacles containing toxic or non-toxic substances. Typical applications include washing machines, dishwashers, chemical tanks, and numerous hospital applications. The hose connection vacuum breaker is a type of atmospheric vacuum breaker for residential and industrial hoses not subject to continuous pressure. They are used for low hazard conditions. Watts manufactures the number 8 series for portable hoses. Typical applications include service sinks, swimming pools, developing tanks, and general outdoor gardening equipment. Watts also makes backflow preventers for specialty situations. It makes one for lab faucets and another for residential water meters. The NLF9 is a double-check valve for lab faucets. It features an intermediate vacuum breaker to provide full protection against back siphonage. A low-hazard product, it can be applied to any lab outlet where a hose can be attached. The Watts 7 series is a dual check valve device that is installed at residential water meters. It is used in continuous pressure, low hazard situations. These 6 methods of backflow prevention make up the basis for a comprehensive cross-connection control program. No matter what devices you require, count on Watts to deliver superior products and service. Follow the lead of the majority of industry wholesalers. According to a 1988 survey, they overwhelmingly named Watts the preferred supplier of backflow prevention devices. Many of our competitors are content to wait for standards to be written and then assemble products to comply with those standards. Watts has played a much stronger role in the valve industry. Our efforts in promoting standards and regulations have resulted in substantial market growth and a safer environment. We've made important contributions in educating the industry on safety issues.
The people at Watts were really a big help to us when we got a committee together on cross-connection control. We were struggling, frankly, to find a way to comply with state regulations and the federal Safe Water or Clean Water Drinking Act. And the people from Watts really gave us a concept, an overview, that we all are convinced will be a great help to everybody involved in the plumbing industry. It's going to meet the questions of liability that are important to water suppliers and local communities. When you bring plumbing code compliance into the program, which was a Watts suggestion, this is going to be a tremendous boost to the licensed plumber, the plumbing contractor, and the inspector, as well as the consumer, because we are going to end up with total protection of the safe water that the public depends on, from the point of treatment to the last tap. And this is everybody's goal. It has been for a long time, but we never really knew how we were going to do it. Now I think we have a program, and as I said, a lot of the credit goes to Watts for coming up with the concept that ties all our activities together.
What are we doing to promote backflow prevention and other safety issues? We hold as many as 600 workshops each year and teach many technical training seminars at close to 100 certified tester and training schools. Training is a crucial service to the industry because without more certified testers, backflow prevention programs cannot be implemented.
Going on the 31 years I've been a member of Local 12, we have always contributed to the education of our membership in our hourly stipend through our contractors. That one of the most exciting courses to come along in the past 4 years has been the development of our backflow course in backflow prevention. The course has cost over $100,000 to develop educational material, etc. Along with that, we've had manufacturers, in particular Watts, who's donated to us over 50% of our instructional supplies as far as the devices go and testing devices. Along with that, a continuous supply of printed material that goes on, again, to continue further educating our members. From what I understand from these manufacturers that have looked at our program, they say it's the finest lab and setup between here and California.
We also work with state and local water authorities to develop backflow prevention programs. We produce many materials on cross-connection control, including booklets, slideshows, exhibits, and videos such as this one. Since 1971, we have published a newsletter, Stop Backflow News, to inform the industry about specific backflow cases. And we have acquired a number of companies since 1984, enabling us to expand our product offerings and continue our tradition of growth. For the complete backflow prevention supplier, turn to the leader, Watts Regulator. We offer you the most complete and innovative line of backflow prevention products on the market, and a great deal more. Manufacturing integration, technical support, industry education, market growth, and most of all, a commitment to safety. Remember, Watts is the name that protects your name.